And with that, I'm running the charge tests here, and I noticed when my solar input gets a little lower, this thing compensates its output. Like I said on my last video, it kind of shares current so it doesn't overload the source at 12.9 volts. And it's boosting it up to 27.5, giving 81 watts. And right now the device itself is using 1.5 watts and the rest of it's getting put in. And so it's just now getting to that point where, see, it just hit 0. It should start giving wattage instead of taking wattage soon, pretty soon. So that's why I started the video. It's almost to that point. The sun's kind of sifting through clouds on and off. And I just cut down some of the draw on this thing to help. It was pulling 100 watts, now it's pulling 63, 64. So, oh, back down to 0. It's kind of balancing between. Right now it's getting almost 0.2 positive, 0.4 positive on the amperage, 0.04. Now it's negative. Yeah, it's kind of bouncing around like a drifter, bouncing from place to place, maybe back and forth. Now it's getting a positive input. See, this number won't show a minus on it, but this one will, to indicate that this is draw. Either way, it's draw until this goes to plus, or to with no negative. So now it's getting 2.3 watts to the batteries. So that pretty much means it's getting about 85 watts to charge. And 60 plus 10 from the inverter is being taken, so that'd be about 70 watts out of the. So 15 watts are going into the batteries approximately right now. So at 83 watts taken out, if it stayed at this rate, that would, take a couple hours, 4 hours, 5 hours. But as the solar power increases, so shall the current going into this, as this allows more. And it'll do that up to 28.6, then it'll stop. 28.8, I think. Yeah. And that'll be it. Yeah. The batteries are working properly now. I did let this thing sit all night on my solar power batteries, or house batteries, I guess you could call them. And it charged up to who knows what time this morning, and I come back in and it showed 887 amp hour or watt hours charged. So where it was negative to, I think it was 600, so it's about 1400 watt hours altogether that it got. Yeah, yesterday before I started charging it was almost negative 600. So, about 1400 watt hours of battery. So, anyway. Of course, with this thing not showing a perfect flow rate because some of the power is being taken by electronics, it may not always be proper on this, for what I'm taking out of the batteries, but it'll be close. It won't always be proper for what's getting put back in, but it'll be close. Because it's really accounting for all of what's going in the batteries, and the rest is being taken by electronics and the power inverter. And so perhaps 3.4 watts is what's going into the batteries. I might have to get a separate meter and confirm that, but not today. I'll get a separate meter and put it on one of the battery wires, not this wire, but around one of the battery wires to check it. Because I want to buy another one of those things anyway for my big power inverter that I run the oven with. It's, let me turn the light on here. It's one of these deals, and goes around the wire. And then this is the transmitter for it. Because that's where, see, this wire goes up to the transmitter. And then it just gives signal to these deals. One is going to my small power inverter for how much it takes, and the other one's just showing how much power is going to the batteries or being drawn out of the batteries if I'm using the furnace, or anything hooked up to here to pull power, or to here on these to pull power. But from the small inverter, it doesn't indicate it, so it never really affects the battery level on these. But I don't care, because I really can tell by where the voltage is at. So that's all I really need to know. And it's pretty obvious when you get down to 12.4 volts on this. It drops rather quickly, and that's when you know you're pretty well out of amp hours. So, and it takes a long time. I mean, holy cow. It's not like it goes right down to 12.4. Or it'd be, on this it'd be, 24, almost 25, which it's going to be less of a pull with this. I'm never, when I get down to 12.4 on here, it'll still run 5 amps okay for all night on the batteries. But if I go to run a big something like 1,000 watts, it goes down. Something like 600 watt draw on these two batteries might pull them pretty good, but it's always going to be 60 to 100 watts. So I don't think this would go down so quickly as all the other batteries do on my main power. So you can see here, it's made it back to 82 now. 19 amp, so almost a quarter amp, 5 watts. Theoretically, when I go to run this, I should be able to pull about 12 to 1400 watts before the voltage gets too low for the power inverter. Theoretically, that is if one of the batteries don't shut down from being imbalanced still. Hence the reason I'm trying to get this voltage back. I should probably hook everything back up to the other power inverter and then just let this charge, but I'm having fun. That's how it is. This might give me a fine thread charge, just this little bit of wattage just trickling in. Probably get a little more in the batteries this way, so I'm not waiting for it to go back down and then plugging it in and getting a little more. you can't just sit and do that. It takes forever. But having it do something like this while you wait, not so bad. I'm going to check the charge controller and see if I got to move this out of the way a little bit. It's not the most convenient thing because this wire is a little short, but I might change that and give it a foot-long connector to go between them. But I like this having the ends on it so that I can put it on anything I want that has connectors the same as them. If I put them on, you know. It's a pretty good plug. Came with the socket, 30 bucks. 20 bucks. Oh, no, it's 26 bucks, yeah. And it's a 30 amp plug at 12 volts. Or any voltage for that matter. Let's see here. What am I doing? 3.4. Okay. Well, there's a pretty good amount going into the batteries, or through it, and some of it will be going to the batteries, and other things that take power. This probably takes, I'm going to say 4 to 8 watts at the most. 8 watts at the most, I bet. It's about that warm. These little guys might take a watt or two to run. This one here, and the one on the power inverter that's, you know, little lights. Little this, little that, little lights. Switch that back over to the output. See, the input's at 26.6, so it's got, you know, supple amount of juice there. I don't know why this one always resets, but it does, and this one doesn't, I don't think. Or that's right, it's got a lower input from over here. It's just going through to this one so that I could get the 11.5, but because of the draw from the other fan, the input is actually 10.8, but it boosted up to 11.5 for me just fine over here. So anyway, it works. Partially the reason it needs to have this other one in there too is because when this powers, oh dang it, get back up there. When this powers things up, instead of the power from here, this will give 24 volts to both of them separately. See? That's how that works. I know it's complicated, and I had to sit for like 3 hours figuring it out myself, so. And it works, just like I wanted it to. I'm trying to remember exactly where I set this, but yeah, 28.8. So that's 14.4 per battery, which is the safe max. The max is 14.6 per battery. And that's when they'd start cooking themselves, you know, if you kept charging them with anything significant. They could probably handle a very small trickle, like milliamps, but that'd be all. Let's see if this will close down today like it's supposed to. Oh, it did its getting stuck thing again. Maybe. Oh, this time it is the plastic thing. Yeah, there we go. Or the acrylic thing. I don't know, I think that's plexi actually. Yeah, probably. Ooh, it likes to fall over. Stay there. Maybe if I put the wire over there. There we go. Yep, it's getting a little more, or no, less, because the sun went away for a minute. Isn't that interesting? Getting -3 on the solar input for this moment. -3.7. So that's what it's pulling from the battery. And it just went the other way. Just like that. So this will be the other way now. Yep. Patience is a virtue. I won't bore you for too long. This is probably not that boring, but still. It's the same thing over and over with just different numbers. I get to monitor it for the day. Yay. Yay me. Really, it's a good stress test for the charge controller right now. That thing was pretty hot yesterday. I may have to upgrade that with, because I need to get more charge into these batteries one way or the other. And these wires are good for up to 30 amps on, pretty short lengths. So, much more than a couple of feet, it might need to get thicker wire, but yeah. Generally, they can do 12 to 15 amps up to in long lengths at this size. DC amps, I mean. DC amps are different than AC amps. AC amps flow a lot easier than DC amps. So be careful of that if you do a solar system. The DC from your solar panel power needs to have adequate wire size. Even if you do them in a series, they need to be at least this thick if you're going to be anywhere near 10 amps. Okay? Higher voltage will equal out for your increased wattage, but the amperage needs to be matched for the wire, or the wire needs to be matched for your amperage, at least double to quadruple what you're going to be doing. This is good for 30, usually does 10 to 20. It's okay. So that's the point. It'll start warming up any more than 25. And it wouldn't do it at a long length. You'd see it going, your input 25 amps and then the output 15 to 18 amps on the end of your wire, because of all the length. Won't necessarily get hot unless you really push some power through it. This funny thing about wires, this little short length, trying to put it to its max and then a little more, will definitely get it hot, But you take a long wire and get it almost close to maximum where it starts dropping down. It's just a drop. It's no heat. Because there's so much wire, you can get up to its max and it's still not going to get very warm. But you're going to see a voltage drop at the end of it, which means less wattage. It's kind of like having a lower riverbank, it's all just kind of spilling out. It ain't making it all the way there. It ain't big enough for the whole river. So that's how this goes, and in so many hours, if it was this much, it'd be 10 hours, but you get the idea. It's not really going to take that long, I don't think, to get going. One of the panels, looking here, Yeah, it's still got a little bit of shade on it out there. The camera just can't see through the window where I'd show you. But once that shade is gone off of that bigger panel I got out there, it will make a huge difference. It still can push an extra amp once the shade comes off the very little bit bottom of it. It's still covered. Them little things, you know, little weeds and stuff on the ground, they make little shadows. So anyway, I'll let you guys go, I guess. Maybe we'll give it another minute or two, huh? That's at 10 watts about now. It's getting there. I'll show you this here is one I'm speaking about. And it's just, you know, kind of getting more and more as a few little bits of shadow move off of the panel. It can't decide where it wants to stay. 6 or 6-1. Anyway, some of them are 0 still because there's no sunlight on them yet. And others are maxed out, like that one and that one. So, that one's starting to get some sunlight. See, that one's still basically nothing. No, and then there's that one. And the other side of that one, you know, the one that matches it, that'll be showing later this afternoon. So, it just takes time. Yeah. 10.3 almost. 11.1. Let me zoom that in so you can see that better. There you go. 145 watts. Looks like took about 40 amp hours of juice plus the solar it put in, you know, yesterday. So quite a bit into them batteries plus the rest of the batteries. Anyway, it's a process. Wind's starting to blow, go figure. I don't know, I don't think you can hear it though. Yeah, almost 11 now. Kind of bouncing around, isn't it? Yeah, I guess I'm gonna end the video here. I've got to do other stuff around here. It's gonna be a while since I'm out of monies. Can't finish all my solar power stuff right now. So I may finish straightening up in this other section. Gotten some other things dried out here. And things put in a box and another trash bag filled up. I gotta figure out what to do with the wires, extra wires, and things I put over there, an empty box and some bags, so I can put a board here. And after I put a board there, I can put a mattress there and sleep there. I might work on that today. Maybe. Maybe not. Slowly but surely it's increasing. Interesting, huh? Anyway, I guess I'll let you guys go. I'm gonna, well, first of all, figure out maybe something to munch on for the morning. I don't eat much in the morning, but this might be one of them mornings. I don't know. You guys have a good one. Take it easy. If you ever want to know more about this thing or where I bought stuff, all you gotta do is ask. Yep, only costs you a minute of typing. Talk to you guys later. Bye.